All right, so we're going to do 31 through 40. So the direction is write the linear equation or inequality for each graph below. Looking at this one, it's on a number line. So this is going to be an inequality that we're going to write. We can use the variable x, and then we look and see what's happening. This is a line that's to the right of 2. Right? It's going to the right from 2. And it's an open circle. So because it's an open circle, that means it's just going to be greater than, because it's going to the right, and it's going from 2, so its x is greater than positive 2 for this first one. If it were a closed circle like this one, then it would be greater than or equal to. For number 32, this is a compound inequality. It's going in 2 different directions, so we can write each one at a time. Over here, this is saying it's less than -1. So we can write that as x is less than -1 because it's an open circle. And then over here, it's bubbled in. So that's why we do less, it's going to be or equal to, right? Because it includes that number. So it'll be x is greater than or equal to positive 3. Because they're going in 2 separate directions, this is an or statement. So it's x is less than -1 or x is greater than or equal to positive 3. So be careful with the bubbling in and the open circles. All right, let's look on to number 33. Right here. So the directions for these, again, it's the same direction. It's write the linear equation for each of these graphs. So we're going to write down an equation for this graph. And remember, you can write it as in slope-intercept. You can write it in point-slope, or you can write it in standard. So for this first one, number 33 here, let's see what we're given, and then we'll decide which one to pick. So first thing, I see there's a point here, right? Yeah. That point is where it crosses the y-axis. That's the y-intercept. That's the b. So I know my b is 2. Okay, so that's the point 0, 2. What else would I need here? Well, I can figure out the slope by looking at a couple of different points. So I can see on this graph, there's another point right here, there's another point right here, etc. So if I zoom in here, let's figure out what the slope is from one point to another. To go from this point right here to this point right here, we go up to there and right to there. So we go up 2 and right 1. Positive 2, positive 1. Remember, slope is rise over run, so it's going to be that 2 over 1. What's 2 divided by 1?
2.
2. So we now have the slope, which is 2, and the y-intercept is positive 2. So which form should we put it in? Which form? How about slope-intercept? Y equals mx plus b. Right, so let's put in the information. The m is 2 and the b is 2. So it would be y equals 2 times x plus 2. There you go. So there's our equation for number 33. For 30, I guess I should say 34. For 34, I'm going to show you a few ways of doing this. The first way is we'll put it into point-slope form. So to put it into point-slope form, remember point-slope form is y minus y1 equals the slope times x minus x1, where x1, y1 is a point on our line. So the first thing that we need, we have 2 points, see? We need the slope. So to figure out the slope, let's look at the graph here. Let's zoom in and figure out the slope on the graph. So it's rise over run, so we're going up that much, and we're going right that much. So we're going up 1, 2, 3, positive 3. We're going right 1, 2, 3, 4, 5, positive 5. So our slope, our m, 3 3 over 5. All right, then we can pick one of these 2 points. How about we use 0, 3?
Yeah.
That's a point on the line. So x1, y1 can be 0, 3. That's a point on our line. So let's take all this information and let's put it into point slope form. So it's going to be y minus our y1 is 3 equals our slope is 3 over 5 times x minus the x1 is 0. That's one equation you can do. Let me show you another one you can do. You can actually do standard form by kind of thinking in your head, how do I make these intercepts work? Well, the intercepts are where? The intercepts are at 3, right? They're at positive 3 right there, and they're at negative 5. So if I wanted to create an equation that looks like this, ax plus by equals c, what number do both 5 and 3 go into?
X equal.
What think about what's 3 times 5?
15.
15. So what we can actually do is we can say, okay, if this c were 15, what would I have to make the ax and the by so that my y-intercept is 3 and my x-intercept is negative 5? Well, I would have to make my this ax, I'd have to make it so that's negative 5. That'd have to be negative 3x, right? Because that, if you figure out that y-intercept or that x-intercept, that would mean negative 3x equals 15 is negative 5, right? The x equals negative 5. There's my x-intercept. If I wanted to find the y-intercept, same thing. This is positive 3. What would that have to be in the b spot to make that equal, to make the y equal 3?
5y.
5y, exactly. So if you don't get this one, if you don't get it this way, that's okay. But it's just a couple different ways you can do it. Both of these equations are saying the same thing. This is point slope, this is standard. All right, number 35 here. We're given 1 point. That's really it. But then you can see right here, there's another point, right, at 0, 0. So you're given 2 points. So what we can do is we can put this one in point slope as well. So we're going to put it into point slope form, which again is y minus y1 equals m times x minus x1. All right, so there's our point. Our point is 4, negative 2.
Yeah.
All right, and let's figure out the slope from this one to this one. So it looks like we're going down 2, and right 4. So our m, our slope, is negative 2 over positive 4. Negative 2 over positive 4, which we can simplify to what? Does that simplify?
Yeah.
Negative 1 over 2, right?
Yeah.
So our slope is negative 1 over 2. Now let's plug in the information. This 4, negative 2, that's our x1, y1. So we're going to do y minus, right? Y minus y1 is y, the y1 is there.
Yeah.
So it's y minus negative 2 equals, the m is negative 1/2 times x minus x1 is 4, so x minus 4. So the one thing I want to change here is I don't like minus negative 2. We can change that to y plus 2 equals that negative 1/2 times x minus 4. And there is our equation in point slope form. Last one here for this type of problem is it's a horizontal line.
Standard.
Maybe we'll see.
I know.
So
It's 0 and negative 3.
all right. So let me show you what's happening here. If I made a table like this, if my x equals 0, what's my y equal on this graph? On this graph, if x equals 0, what's y?
Negative 2.
Negative 2.
Yeah.
If my x equals 1, what's my y?
Negative 4.
Negative 2.
Negative 2, right? It's a horizontal line. How about if it's my x equals 2?
Negative 2.
Negative 2. Any number, any x value is going to yield a y value of -2. So what that means is that all x's, or let's see, sorry, my y will always equal -2, right? On this graph, my y will always equal -2. Does that make sense?
Yeah.
Y always equals -2. Okay? So because y always equals -2, what the equation is saying here is y equals -2. That's it. That's my graph.
Yeah, that's it. Like,
Y equals -2.
like this one.
So that's how you write the equation for a horizontal line.
Yeah.
If it's a horizontal line, it'll be a y equal whatever that number it's at. Okay? Questions on that before we do the last four? Okay? The next set of four, it says we're going to graph the following linear equations. So we're just going to graph them. This one's similar to the last one, right?
Yeah.
That one was y equals -2. For this one, this is saying that all x
Equals
will always equal what number?
3.
Exactly. It'll always equal 3. So if x always equals 3, let's graph a few points. So like it'd be 3 here, it'd be 3 up here, it'd be 3 down here. Every point's going to be 3. So what type of line do we have? A vertical line. Good. So if you have x equals a number like this, it gives you a vertical line. So there's my graph for this one.
Just like that?
Just like that. Okay? 30.